Hello, everyone. Welcome to today's session. I'm really pleased to welcome you today to our webinar on professional SIP communication and monitoring. Today, you will learn how to manage complex SIP workflows, and you will learn also why the EBU and Radio France International chose Ferncast SIP services. Thanks for joining us and taking time out today. This webinar will last 45 minutes with some time for questions at the end. But please feel free to write your question in the chat, and our Ferncast experts will be happy to answer them. You have the chance today to win a Ferncast t-shirt with our traditional quiz. So please stay tuned. You might be a winner today. Last information, I will be sending out a recording to all of you by the end of the week. Let me introduce now the speakers of the day. Thomas Schlien, software engineer at Ferncast. Tobias Dornbusch, our expert. And Bernd Geiser, senior audio engineer at Ferncast. Let's have a look now at the agenda. Bernd Geiser is going to give technical overview of the session initiation protocol. Then Thomas Schlien will present the Ferncast SIP infrastructure for operators, including SIP servers, new features, and customer use cases. And finally, Tobias Dornbusch will showcase some example of SIP application, including a demo. I'm going now to leave the floor first to Detlef Wiese, Ferncast CEO, who is going to give you a short introduction of Ferncast team and offering. Detlef, the floor is yours.
Thank you, Virginie, for this nice introduction, and good morning, everybody. I see people from a variety of countries in Europe here. So a few words about Ferncast and our objectives. So first of all, I would like to really emphasize that Ferncast is a team of people before going into subjects which we are dealing with. And that's probably the most important, because that's where people talk with, get consultants and advice, and I would define our group of people as approachable, so we can be contacted, advisory, helpful, supportive, and also friendly. That's the basis actually for what we are doing. And what we are doing is really, Ferncast is I would say an audio logistics company, because we really deal with bringing the audio packages from one location to the other. We transport audio. We make sure that it arrives really safely and stable. We make sure that for 24/7 operations, you do not have to deal with dropouts and issues. That's really the core where we, the team, take care of, and also spend a lot of time to make sure that the software we are doing is robust and applicable, and at the end makes people happy, so that the decision they made once for Ferncast is fruitful and really beneficial. So we bring really audio from A to B, and of course also we bring audio from A to many destinations. On this way, lots of things can happen, and lots of things we take care of. I think today we have one important subject, which is complex SIP operations, how to make them also, and get in touch with them in a more simple and intuitive way, and what type of applications are all behind. So that's the key, really. We transport audio, and we are an audio logistics company. So let's see what we have on offer. This is a variety of things. It's always really about the transport of audio. Let me start with the last one here on this slide, the consulting. Whether this is pre-sales, post-sales, or it is even without sales. I mean, we consult, we give advice. We have highly experienced developers and people in the field of IT, protocols, audio, signal processing, and really experts on the system architecture. So, and the system architecture quite often is in the foreground, and there are possibilities to solve problems or to cover, to answer challenges in different ways. And that's, I think, where we are also therefore to consult. So once we have consulted, and let's say there's also, of course, which is our preference at the end of the consulting, also solution which in the middle or somewhere has a part which is from us, from Ferncast, then we offer this as software applied on hardware. So we actually ship also hardware, and of course, in the more and more demanded cloud services. Those are our 4 offers when it comes to audio logistics applications. And the applications, yeah, this is just, say, the main area where we have started. Ferncast is still, I would say, in this industry, in this also traditional industry of radio, is a very young company with a bit more than 4 years. And our main focus so far has been really the streaming backend in radio stations to make sure that all the streams reach the kitchen radios, the smartphones, the tablets, and so on, with all types of features and protocols. The reporting, I think that's probably also something which is interesting when we talk about SIP, because that's still quite often in the foreground. There are also other possibilities, but SIP probably is one of the key things. And on-demand services when it comes really to more file-orientated processing, but also more. I will not go too much in detail, but just show you the start of things which are underneath those applications. So of course, there are lots of technical features or protocols, but for streaming, let's say, there are also things like maybe loop radios or cue points or logging, recording, file play. On the reporting, there are lots of interesting combinations, maybe even simultaneous streaming and talkback and interview. On the on-demand, there is probably very interesting also the focus on loudness adaptation. So I will not go through all those things. We have separate webinars also for certain topics. But on the last column, maybe it's interesting. So of course, beyond streaming, reporting, and on-demand applications, we have lots of other applications for the software which we are developing, and this is studio transmitter links. It's on DAB, demuxing, monitoring, FM, DVB, multiplexing, demuxing, and lots of more things. And so I would say we cover a lot of areas to make a radio station work, to provide back-end solutions for radio stations to be stable and have a good offer for you guys, whatever you come to us with. And beyond maybe the last sentence, if there is things outside or out of the box what we have on offer, then of course also we give consultants what can be done either by ourselves or whether we need other pieces of puzzle stones to put together to make the solution work. And then back to Virginie.
Yeah, thanks, Detlef. Let's go now deeper in the SIP workflows. Bernd Geiser is going now to give an introduction of the session initiation protocol.
Yes, hello everyone, also from my side. Yes, my task today is to give you a very brief overview of the SIP protocol. I would guess a lot of you are aware of that, but the idea is to make some common ground so that can make clear how our offers play together. Okay, so the SIP protocol, standardized by IATF in these requests for comments, as listed, is not a media transmission protocol, which is a common misconception, but probably most of you are aware. It's a control protocol, so its function is managing sessions. So initiating sessions, maintaining the sessions, terminating sessions, and such stuff. But the application, which is behind that, is of course transmission of media, so that can be voice audio or video, or can also be text messaging. To be able to do that, and we are primarily, of course, dealing with audio, certain formats have to be negotiated, and there a second protocol comes into place, the session description protocol, one party announces what formats are supported, and the other party just selects one or drops out what is not supported, and there's a negotiation process going on. I will show a little example later. This SDP protocol is transported in zip messages, so it can be considered a part of that, but still we're not yet transmitting media. This is done via different means which are negotiated there, and the media stream transport is the common thing. It's via UDP, and on UDP there's the RTP protocol. Sometimes it's encrypted with SRTP. That's the common way. Okay, and on the next slide I'm going to show you how zip is playing its part in such a system. It's a request response type of protocol where you have two parties. That's the traditional phone call, for example, and one is going to call the other, and you're sending invite messages. Here in this example, you're being redirected to another server, to this proxy server, and you have to send this invite again. This invite is forwarded to the other party, Boris. The phone rings, a ringing message is coming back, and everything is acknowledged. And at some point, once the media has been negotiated, the RTP over UDP media session is set up. And this media flow can be, as shown here, directly between the peers. Usually if they are both on public internet, or if there is some address translation going on, if they're in private networks, but then you need helper servers. Or another possibility could be that also the media, this RTP, is handled by the proxy server. So Alice sends its media to the proxy, and the proxy takes care of getting that delivered to Boris, and the other way around. And at the end of the workflow, someone hangs up the phone, and there's a bye message being sent by the proxy to the other party, and that is acknowledged, and then the call is finalized. So that's just the basic workflow of how that's working. And important part in that, the session description protocol on the next slide. Weird looking text snippet which is exchanged, which gives you the basic information on what the session would look like. Important is this line starting with M. It says it's an audio session, and we want to transmit it over RTP. And there's a number of lines, numbers saying 96, 14, 10, 11, 9, 8, 0. Those are the media formats that are offered for the session. And the A lines below specify them further. So it's Opus, MP3, linear, insert separates, stereo, mono, G722, standard telephone codec, or as a very common ground, as the latest fallback, so the PCMA or PCMU, so the A-law or new law telephone codecs, very old, but everyone supports this. So such a thing is prepared usually by the caller. So with all the things the caller desires or supports, and the other party can just drop formats which are not desired or not supported. And usually for the session, the first one in the remaining intersection is chosen as the codec which is used for establishing the session. So that's the SDP. And now we can bring everything together on the next slide with the network elements that are present in the zip system. You have seen it in the message flow already, at least part of that. So first and most important, I guess, for the users is the user agent, which registers the zip account where you can configure what media type you desire, or your preference list, and so on. And yes, that's one part we as Ferncast provide. It is integrated in our main software product, aixtream. And later on, Tobias will give you more details on that, how you configure everything, and how you can make the most out of it. Then in a zip system, as you have seen, there are different kind of servers. You could have a registrar server. So this is what you commonly think of as a SIP server, because you log in there with your username and password, and you have your account there, and the server knows how to reach others and such stuff. So that's the registrar server. There might also be SIP proxy servers, which relay SIP messages to other parties or other networks. And there can also be media proxy servers. If you do not want a peer-to-peer connection, you can send your media directly to the media proxy server, and this one relays it to some other party, to the other participants. So all those functionalities are provided with the Ferncast SIP services, and they play well together with, of course, with aixtream, but also other clients. And yes, Thomas Schlien will fill you in on that later on. Okay, yeah. And finally, of course, a network system with SIP can even be more complicated. You can have redirects in a redirect server. You can have session border controllers and gateways. Most of them come into play if you really want to go into the public network and or mobile telephony and so on. But yeah, that's just to put into context what we are offering in a SIP ecosystem. Yeah, that was my part. Thank you.
Thanks, Bernd. Now it's time for our quiz. So be concentrated, be fast. Here's a question today. What has been the highest level of a human being's voice measured in dB? So you need to be fast, and the winner will be also the one who will give the closest answer. Please write in the chat to everybody so we can look at the end of the webinar at all the answers. Now, Thomas Schlien is going to present the Ferncast SIP infrastructures, including SIP servers, new features, and customer use cases.
Yeah, welcome everybody, also from my side. So I want to talk about the Ferncast SIP service today. So they allow you to make centralized calls with a call diary history and a phone book. You will have like an error event log for administrators. Yeah, we support a broad range of codecs, what is not very surprising because this is mostly user agent stuff. So yeah, so the server will support everything there. There is also some protection integrated against SIP attacks, which is very important because if you have ever had a look at a log of a zip server, you will see that there are a lot of attacks and tries to make calls to numbers which cost a lot of money. So it's always good to have a protection against these attacks. Then we also have some live monitoring of zip connections. You can see what accounts are registered, with which devices are in there, and so on. This is actually a part of our custom solution. And yeah, you will have, if you are a customer of our SIP service, you will have the possibility to manage and rename your SIP accounts freely. That's for power users at least. And yeah, you can limit calls participants in the customer's domain if you like, or even more sophisticated, as I will show later. Here are some use cases. We actually implemented SIP servers for the European Broadcast Union and for Radio France Internationale. So for both, they were important that they get a highly available ZIP server. And for the EBU, we deployed it on one of our servers and maintain it for them. They use it for transmitting audio from one partner to another. So, and that's mainly a backup solution for them. They have a other system that's a bit different, and they use it mainly, and they wanted to have a strong backup. So if something fails, they can use our service, and they do it from time to time. So yeah, and they wanted to have an interactive phone book, which actually enables you to make a call from a web interface between two partners, and also we'll show it in the demo later. For Radio France Internationale, the situation was a little bit different. They wanted to have the server on their side, so we made an on-site installation for them, and they operated by themselves. So updates and so on will be also managed by us from time to time, but it's mainly under their full control. So we do not have the access to it all the time. So only if they need help from us. Yeah, they wanted to have some specific stuff. They wanted to have live monitoring of their DIP connections. They wanted to see their registered accounts, and they wanted to have some kind of blocking or allow mechanism. And yeah, this is also something I will show in the demo in a minute. So the advantage of our services are so that we have an extensive fulfillment of zip requirements. We have the ability to develop the solution to fulfill all stuff you want. So if it's technical possible, at least. So as you will see, we have made in WebGUI for controlling stuff for our customers. So we have the technical competence for this. So we, for example, can help you with setting up the firewall, which is always a big problem with the zip communication. Yeah, we do hands-on and fast support, therefore, and all for an affordable price. So next, I want to go to the demo. So I switch over to this here. I have to move that. Okay, so I hope you can now see the interface of the zip server. So I will start with the dashboard. So this is one of our test servers. So it's zip3. And if you are a power user, you get access to this interface. It's based on the Zipwise zip server, and you can have an administrator account there. And then if you are a customer of us, you can, for example, add subscribers or rename them or block them or deactivate them. And you have a lot of other stuff that you can do. One important thing is, as I told you before, are the security features. And here you see, for example, the security bands. So if an IP is malicious and you tries to do things that is not allowed to, then it will be blocked after some time. And you also have the ability, if you see you made a mistake, for example, with the password multiple times, then it will also be a banned user. And then you can say here, okay, unban. I do not want to do this for this year because this is actually an attack again. So someone tries to log into the server and make calls. But yeah, that's not so important because we have these features here. You also have some kind of monitoring and statistics, so you can have a look on the system to see if everything is fine there. So, and next up, I want to show you our custom overview. We have made this available for our customers. This is more or less version RFI is now using. So at first you can see the call list. So the recent calls here, for example, you see duration, you see the source IP, and you can also see that status of the call. So, and now if I do a call on the server, so this is aixtream, which will be later explained by Tobias, then you can see that the call is now active here. You can see who is calling who. You have a duration and the start time. And yeah, and you can also see here the active subscribers tab. And here are all logged in devices. So if you are registered to the server with an account, then it's shown here, also with some more information, for example, which kind of device it is. So here I use the Ferncast aixtream, but it could also be like a other codec from other vendor. And you can also see the source IP here. So it's just for information. And it's customizable. So if you would like to have other information there, we can also adapt it to your needs. So the call is still ongoing. That's why these boxes are red. So I will stop the call now for a second and go back. And then you will see after some time that actually the call is now gone. So here is no call anymore. No active calls, and the subscribers get gray again. So to show you that everything is fine. Another feature that we actually implemented for RFI is the allow list block list feature. So they wanted to have the possibility to actually say which domains they want to allow for calls. So obviously, if the callers have accounts on this server, they are always allowed to call each other. But from external, you have to be, in this case, because it's allow list, you have to be on the list. For example, now we have a wildcard for zip.ferncast.de. And if I call, for example, with such account, which is here, for example, so then the call is getting through. Then you can see that someone from zip.ferncast.de is calling an internal account. So that's working because we are on the allow list at the moment. So what I want to show now is we now switch to block mode. And now I need to move that away. And then submit the changes. Then it takes a little time and then it's actually activated. And if I now try to call again, then I'm blocked. So you can see that now I cannot call the account on the zip server anymore. And you can also see that here, so I tried from the zip.ferncast.de domain and I was blocked because I'm on the block list at the moment. Yeah. So, and it's very easy to change it back. So just submit it and then you get the allow list back again. So, and you can also see that these are two different lists and you can decide on the use case which one you want to use. So the last feature I want to show you is the active phone book. So if I click on the gray one here, you can see that it says if it should establish a call from one to another. And if I click call now, then hopefully it works. Yeah, then you can see that there's a call now to this specific zip account. Yeah, that's more or less it. So yeah, that's what I wanted to show you and hope you have seen what we can do. And as always, we can adapt stuff to your needs if it's necessary. So yeah, thank you.
Thanks, Thomas. If you have some questions for Thomas or Bernd, please use the chat in Zoom. They will be happy to answer them, or at the end, we will also have a Q&A session. Now, Tobias Dornbusch is going to showcase some examples of SIP application, including an aixtream demo. Tobias, the floor is yours.
Yeah, thank you, Virginie. So let us move on over here. Yeah, so as Virginie just said, I'm going to first represent a few examples of slightly more different SIP use cases, besides, the classic communication use case of calling from an OB van to a studio. And afterwards, I will present how actually SIP setup and so on works in our audio transmission software aixtream. So, but first on to the use cases. One use case that is very interesting and that we have also had, technical issues here, that we had a recent webinar about is a live commentary use case for the German football club Mainz 05. At its core, actually, there is not not on the first layer a SIP aspect to this, because at its most basic, it's about creating a fan radio, obviously via the commentary, which is then offered as an Eiscast stream on their fan radio website. However, where the SIP comes in, and what is a very interesting aspect, is that interviewers, also listeners and so on, can call in, including via regular phone lines, which would then get translated to a SIP call, or they call in directly via SIP. And this way they can get directly connected to the commentator, discuss the game, maybe while it's going on, or maybe in some sort of after game discussion round, etc. And yeah, be also added to the live stream, which is then output on their website. And what's also nice about this specifically is that the commentator has a large amount of freedom, or a large amount of options for how to handle the audio side of things, like so they can add jingles to the ongoing transmission. They can go into a off-air pre-talk with any callers, just to sort of get them ready for the conversation that follows. Then, of course, decide when to take callers into the conversation and so on. And all of this is done via a fairly simple interface. We're actually going to see this for a moment later, but you can also see it here on the side here with the laptop, giving you an idea. But as I said, you will get a closer look at this in a moment. And this is also, just as a side note, a very nice example of a fairly compact use case. So you actually have the aixtream running on this mini PC here at the top of this Focusrite Scarlett audio interface that you see on the picture pretty centrally. And then the commentator is controlling this via a laptop. This could also be a tablet, or a phone would probably be a little too small as far as the interface is concerned. But I suppose if it has a very large screen, then even that may work. On to our next example. So I already mentioned this aspect of translating regular phone calls to SIP. In a lot of cases, what you need for this is a so-called peering partner, for classical phone lines, that is. So that would be a company that basically translates regular phone calls into a SIP call for you. And then, of course, it can interact with, regular SIP infrastructure. But what you also have is PBX systems, private branch exchange systems. You may know this as oftentimes the phone systems internal to, for example, a specific building or a specific network. And of course, in a lot of cases, you also want these to interact with SIP infrastructure. For instance, you have a SIP call coming in from a remote site, and you want to route this through the building's internal PBX infrastructure, for example. And this is in fact also something we do for our customer, both by providing the systems on the remote end, SIP systems in the internal end, so there's direct SIP communication going in between them, but also going through the PBX system, so people can just pick up SIP calls via their phone at their desk, for example. And one interesting aspect or feature that we added specifically for this is that is support for the SIP info system. This is basically a way how to transport DTMF signals via SIP lines. And this is interesting because, especially when there's a PBX system on the other end, you can use these DTMF signals to control, for instance, the routing or other aspects of the PBX system. And the last one I wanted to show here is a slightly more complex example of remote contribution and processing. So this is fairly similar to what I would see as the default SIP use case. But in this example, this is actually also a sports event. Multiple codecs at the venue record the atmosphere, the ambience, the noise of what's going on, but also, of course, interview talks, etc., commentary even. All of this from all of these different sites across the venue, all of this is sent via a SIP call, via SIP calls to a central unit and a concentrator unit effectively, which of course can monitor all the channels if the input is okay, etc. Even do like automatized reporting if there's any issues. And then, of course, also mixes the channels, processes this. For example, we have a loudness control that could be used here for automatic volume adjustment according to your parameters and so on. And from there, once all of this is done, it's then transmitted on for play out, being mixed in, for example, the final TV broadcast or similar. And yeah, this way you can combine lots of different features of aixtream for very complex use cases, which brings us to aixtream itself, which I'm going to show now. There we go. So this is the second part of my presentation. Yeah, as I said, we're going to see a bit of a demo specifically with a focus on what we can do for SIP communication. However, for all of this, what I'm going to say to make sense, you need to first understand what the pipe concept is. So the pipe concept is how we display an audio workflow. Effectively, the entire audio workflow from the input to the output is displayed as this row of elements. These are these colorful circles that you have here. The idea is that to allow the user to see exactly everything that happens with an audio signal from input to output. So in this top example that you can see here, the input is actually a URL stream, so a stream that actually exists in the network or on the internet is used as an input. The volume control is enabled, level is being measured, and then in this case it goes out, via one of the audio interfaces. For example, this could be a simple restreaming for monitoring purposes. So you just take the stream from the internet to then listen if everything arrived well there. But by the same pattern, you can set up just about any kind of audio workflow. So here we can actually see the broad range of sources that are supported. So that's, of course, the inputs, basically. Audio processing is also something that I mentioned, including the loudness control. But for web radio, for example, metadata insertion could also be interesting. Of course, we also support a broad range of encoders, as has been mentioned. And then these things are your outputs or the stream destinations, as the case may be. Of course, we're talking about SIP today, so I would like to show a very quick example of how a SIP template pipe would actually look like. If we're going with the classic example of you have an audio interface connected, could be like analog microphones, as we've seen earlier, or maybe a digital audio interface with like MADI inputs or ASIBU inputs, then you would require the audio element. Usually, in most cases, you probably have a level meter and volume control. That's just a very standard thing to do, understandably. And let's say you want to encode this stream with Opus, and then usually, anyway, I'll show some alternative ways how to handle the encoding later. And then, of course, have this go out as a SIP stream. This would be the basic way to set up a pipe. However, as you see here, there's actually an error blinking here, because for SIP pipes, it works slightly differently. As I said, I'll show that in a moment. But just to give you a basic idea how it looks for a unidirectional pipe, this would be a rough example. Of course, it wouldn't have a SIP end, but for example, RTP or whatever. Now I can do the detailed configuration by simply clicking on an element. And then I have specific menus that, based on the element. So for example, for the audio input, I can select which channel inputs I would like to use. For instance, here, this Focusrite Scarlett. To this system, there's actually a lot of interfaces connected, as you can see here. But yeah, you simply pick the channels that you want to use for the input here and then click Save. And if this was a normal pipe, I could set things like encoder bitrate and so on, and some codec-specific settings by defining this here, and so on. Now, I promised I show you how it is a little different for SIP. And for that, I go to the phone book. So the phone book is, of course, where you can save all your SIP contacts, the SIP phone numbers that you want to use, and also configure how the system is meant to behave when you receive a call from a contact that you don't know. But we're just going to look at one example here. This is one of Thomas's SIP accounts. So, of course, as you would expect, you can define the address that, the actual address you're calling. You can also choose which SIP account you want to call from based on the ones that you have registered on the system. You can also, as I've mentioned with the use cases earlier, you can now also set a DTMF sequence that would be sent when a call is started. And here at the bottom, then, you pick which pipe the system should use when a call is started with this contact, both on the sending end, which is this one, and as well as on the receiving end. So basically, via the pipe templates that you have configured earlier, you tell the system how to handle specific calls with specific contacts. And this also means that you can define very specific SIP workflows. Of course, there's the classic audio comes in via an audio interface, goes out via SIP, and then, of course, the audio that you get back, because SIP is usually bidirectional, comes out of one of your audio interfaces. But you can also do more specific things, like, say, your audio goes out, but the audio that comes back in is recorded, or, as we've seen earlier, is added to, or also added to an aixtream, for example. And all sorts of complex workflows can be configured via these pipes that we've seen earlier. Okay. Also relevant for SIP specifically are the widgets and the dashboards. Just very quickly, the dashboard is effectively a way for you to configure your own monitoring and control hub. So all of these elements, as you can see here, as I click through different dashboards that have been configured on this system, are or have been specifically set up this way from components, which we call widgets, that have been put together in these combinations. And what we're seeing here actually is the user interface as defined for Mainz 05 that I showed you earlier with the use case. So, of course, you have some channel overview here, obviously active connections with their level meters, etc. And here at the bottom, as you've also seen with Thomas's part, you have like this mini phone book where you can see the contacts that you can call, obviously with the addresses. You see the level meters, as you've also seen earlier with Thomas. You can choose on the fly whether you want to change the account that you're calling from, and so on and so on. And you can also change the call profile on the fly. And this is also something I will show in a moment here, because that's also very interesting for convenient SIP negotiation. One last thing before that I would like to highlight is the quick actions. So this is actually a widget that is designed to basically build this custom control panel where you simply create all these buttons that you can see here to control the workflows. So basically you can enable specific inputs, outputs. So say moderator 1 is supposed to talk, then you click that button. If you want to mute them, then you click that button. Fairly straightforward. You can add jingles from files by the click of the button. And of course, this is also how you can control things like the this off-air pre-talk that I talked about earlier. All right. And call profiles, as I mentioned. Actually, I'll show this on this one here because we have a greater selection. So the call profiles, I suppose in system from some other vendors, they may even be called codec profiles. This is actually how you define how or which codecs should be used when you start a call and which codecs should be supported when you receive a call. Now, if you make a very specific configuration, then of course you can simply use this to say, if I make a call, then this should be an Opus SIP call. And if the other side doesn't support Opus or rejects it for whatever reason, then we just don't want a call. That's of course the extreme end, let's say. So that's why there's only a single Opus encoder here. However, when you include multiple codecs, then it's sort of like a priority list. So if I made a call with this webinar call profile, I would first suggest to the remote side to have the call in Opus at 64 kbits, but maybe they reject it, or maybe they don't support Opus for whatever reason, because it's like an ancient codec, for example. Then I would suggest, or the system would suggest AAC at 128 kbits, but if we're assuming this is an ancient system, then it may also not support AAC either. So we then suggest MP3 at 256. And if that is then also rejected, only then the call would fail to be successfully negotiated. So it wouldn't happen. Of course, there are situations where you have no idea what the other side could support. So we also have a default call profile, which simply includes every single codec that you have unlocked on your specific aixtream system, just so something can be found for a call. And in a similar way, of course, you can also create a very long call profile lists. As you can see here as well, the call profiles can also be used to do some other general call configuration, like the size of the jitter buffer, for example, things like reconnect behavior, whether calls with that call profile should be immediately restarted on register. So this is, of course, very interesting for monitoring situations, or, well, when the network circumstances aren't quite so safe. So you may have occasional call drops and so on. Then this is, or register failures. Then this is very nice. Yeah, and that was just a very quick overview of aixtream for SIP. Of course, as you can see here with all these menus, there's a lot more to explore, but this may have given you a bit of a taste of the broad flexibility and all the things that you can do. And with that, I would go back, or give back, to Virginie.
Yeah, thanks, Tobias, for this for the demo. We will, and you organize other webinars on other themes to show more of aixtream. I think we are now coming to the end of the webinar. Let me now. So here the answer from the quiz. The answer is Jill Drake in October 2000, and it was 129 dB. So we had some answers in the chat. We had 121. We have 129. So the winner is José Luis Granado for the right answer, 129. I think Detlef, that's the right answer, no? Can you confirm?
Yeah, it's perfect. I mean, unbelievable, but this is actually also in the Guinness Book of Records. 129 dB. Jill Drake has been a class teacher assistant at that time and was during a festival, and there was a measurement, and yeah, she got 129 dB.
Great. So we have one winner. Congratulations, José Luis. So you win a Ferncast t-shirt. We'll be happy to send it to you soon. We are now at the end of the webinar. I don't know if you have some question. Please feel free to unmute yourself if you have some question. We are all here for you. I didn't see any question in the chat.
We made everything as clear as it could be.
Yeah. Yeah, and we are now coming at the end of the webinar. Then maybe just one more information. We will be at the IBC in September. We will be in Hall 8 at the booth F83, and we will be happy to welcome you there. There will be a new product and new services from Ferncast. So if you are going to Amsterdam, please visit us. We will all be there for you. And if you have any questions afterwards, please contact Tobias Dornbusch, our expert. He's always there for you, can answer your question. He can do a personalized demo also for you if you have a specific use case or request. So I would like to thank you all for your time, for joining us today. Thanks to the Ferncast team. Thanks to all the participants. I wish you a nice day still, and hope to see you in our next webinar. Goodbye.
All the best. Bye-bye.
Goodbye.
Goodbye.
Bye.
Thank you.